All right, let's look at some limit laws. Whenever you have limits and you have two different functions here being added inside that limit, it's fine to break that apart as separate limits, still approaching that same value that was defined here. So in this case, A. Similar, you can do the same thing if you have subtraction, adding and subtracting, same thing in essence. If you have a constant c that is being multiplied to that function, you can pull out that constant and just focus on finding the limit of that function and then multiply the constant back to it. Multiplying and dividing, if you have a limit approaching something, just like adding and subtracting, you can split that limit up into two limits, still approaching that same value in each one, and that answer should come out to be the same answer as before. And division, same thing. The one thing we got to remember with division, the property works as long as that limit in the denominator does not end up equaling 0, otherwise we got division by 0. A few other limits here. You can do the same thing with exponents. If you're approaching something where there's a power outside of that function, you can find the limit and then take that, whatever that answer is, to that power, and it ends up being the same answer. A limit of any constants, always just going to equal that constant. Number 8 is pretty self-explanatory. If you're approaching or have the limit of the function x and you're approaching a, it's going to equal a because it's a continuous function. And then any exponents or square roots, which we know are also exponents, will also work if you are approaching that value. Let's take and look at one example here. Find the limit of these with a graph. So we don't actually know what these functions f and g are, but we can still figure these out by using the graph to find the function value. So in A, what we can do here is we can change this into two limits, because we know if we're adding that it would be the same as this limit plus this limit approaching the same thing. And then this 5 here is a constant being multiplied to that. So what we can do is slide that 5 outside of this and just find the limit first and then times it back by the 5. And these two limits we should be able to now find from the graph and answer this question. So what's the limit of f as we approach -2? So -2 is right here. What's the value as we approach from both the left and the right? Looks like it has the same y value here of 1. And so this is going to equal 1 plus 5 times. Now let's do the same with g here. Function g as we approach -2 from both the left and right has the same value, and it looks like that value ends up being -1. And so now we can finish solving this. We got 1 minus 5 is -4. So we can still find that function even though we don't know what the functions are by using the graph. B, we can do something similar here. And this limit, we should be able to split these up as limit as we approach f times the limit as we approach 1 of g. And we can do something similar now. So on this one, if we find these limits and multiply the values together, we can find that. On this one, as we approach on g, let's start with g as we approach g here. It looks like the value from the left and right are not matching up on this one. It does on f. As we approach 1 on f, it looks like we get that same y value of 2. And so here, because this one does not exist, I can't technically use this to do it. So if you did have one like this, you would want to go back to the definition then and see what's the limit as you approach 1 from both the left and right, and see are both going to be equal. From the left here, that means f would be approaching 2, and g would be approaching this y value of looks like -2, which would equal -4 from the right. F is still approaching 2, but g now is approaching -1. Are these two approaching the same thing from both sides? No. So then we can conclude on this one then that this limit does not exist. They got to be the same. On the last one, we should be able to split these up into two different limits again by taking what's the limit as we approach 2 from the top over what are we going to get when we approach 2 of the bottom one. But I think we're going to end up with a similar result. Oh, sorry, we're approaching 2 on this one. So on this one, what's our values here as we approach 2 for g of x? It looks like from our graph that the value of g of x here from both sides as we approach 2 is 0. But that's going to lead us to a problem here because we can't have dividing by 0. So this limit also does not exist. We don't even know need to know what the top one is.